Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in this video we will solve a problem based on how we can interface a memory chip with 8086 microprocessor. So let us take a problem. So our problem is we have to interface two 4K into 8 EPROMs and two 4K into 8 RAM chips with 8086 microprocessor, and we have to select suitable address map. Now here in the question we are having two ROM and two RAM chips, okay. The two ROM chips, they are each of the size 4K into 8. And the two RAM chips, they are also of the size 4K into 8. So if we talk about the ROM, we are having total 8 kilobyte. And for the RAM, we are also having 8 kilobyte. So to address these memory chips, how many address lines of the 8086 microprocessor are required? We can calculate by using the formula 2 raised to the power n equals to capital N, where n, it is the number of memory locations in the memory chip, and n is the number of address lines. Now number of memory locations we can calculate. We know that 1 kilobyte of memory, it has 1024 memory locations. If we are having 4 kilobyte of memory, we are having 4096 memory locations. So if we are having 8K memory, then we can calculate the number of memory locations. 4096 plus 4096. So that will be the total number of memory locations. So if we calculate the number of address lines, we can calculate by using this formula. So 2 raised to the power n equals to this 4096 plus 4096. Okay. So if we calculate the number of address lines, it will come out to be 13. Because 2 raised to the power 13 equals to 8 kilobyte of memory. So number of address lines n equals to 13 here. So 13 address lines will be required to address these 4 memory chips. 2 for the ROM and 2 for the RAM. Okay. Now 8086, this microprocessor, it is having 20 address lines from A0 to A19. Now out of these 20 address lines, only 13 are required to address the memory chip, that is from A0 to A12. The remaining address lines from A13 to A19, they will be used to form the chip select signal. Along with the bus high enable signal BHE and the A0 address line. Okay. Now when we have studied about the steps or the procedure when we interface the memory with the 8086 microprocessor, so in that procedure our first step is to is to arrange the available memory chips in such a way that we get a complete 16-bit data width. Okay, we want 16-bit data width here. Now each memory chip, you can say that it can store 88-bit of data at each memory location, but we want 16-bit data width, so we are going to arrange the two RAMs and two ROMs in parallel to each other, so that when two RAMs are arranged, then upper RAM will give us the odd address and the lower RAM it will give us the even address. So when we talk about the arrangement of these four memory chips, we will arrange it like this, so that each is providing 88-bit of data. So together they will give us the 16-bit of data. One will give us act as odd memory bank, second will act as the even address memory bank. This is for ROM and this is for RAM. So for RAM we will have one for the odd and one for the even address memory bank. So in this way we are going to arrange the memory chips. Now next step will be to find out the address map, because in the question we were asked that we have to select the suitable address map for addressing these memory chips. So we will use the 13 address lines from A0 to A12 of the 8086 microprocessor to address these ROM and RAM memory chips. Let's see that what the address will come out to be. So there are 20 address lines of the microprocessor. Now out of these 20 address lines, we have to use only 13 address lines. So from A0 to A12, they will be used by us. Okay. Now we are having two memory chips for the RAM and two memory chips for the ROM. So we can use a address line 813 to differentiate between the RAM and the ROM. Okay. Now remaining address lines are A13 to A19. So we are going to use these address lines for the chip select signal, and these address lines are for addressing the chips. Okay. Now if we will decide for the ROM. So for ROM, if we take that A13, it is taking the value 1 and 1. These A0 to A12, they can take any values. They can all be 0 or they can all be at 1. Okay. So there can be any of the combinations here. Okay. From 0, 0 to 1, 1, 1. And this A13, it is always at logic 1, because here we are using this address map for the ROM. Now these A13 to A19 we are using for selecting the chip select signal. So this A13 to A19, it will be at logic 1. And this is all we are taking for the ROM. And ROM, the size is 8K into 8, because we are having two memory chips, each is for 4K and 4 kilobyte of memory. So total we are having ROM 8 kilobyte. So the address range, it will come out to be, if we combine this will be 1 1 1 1 means F, 1 1 1 0, that means if we are having this 0, then it will be E, then again 0, and then 0. So the address will come out to be F E 0 0 0 H. And if we take this value, then it will be F F F F F H. H means that this address is in the hexadecimal notation, and this is the address FE000. 1111, this will be F, 1110, it will be E, then 0000, it will be 0, then again 0000, it will be the next 0, and again 0000, so it will be the next 0. So this is in the hexadecimal notation. We are getting the address range as this for the EEPROM memory chips. Now coming to the RAM is also of the same size, 8K into 8. So again the addresses. Now we are using this A13 for the selection that whether ROM is there or RAM is connected. So we can change this value. We can have 0 for the RAM, and these A0 to A12, these 13 address lines, they can take any value. Okay, so it can be 000 till 1111. So these 13 address lines, they can take any value from 00 to 111. This 00, we are taking this A13 to select the ROM and the RAM. So this is for RAM. Also these lines A19 to A14, they will be at logic 1. So if we calculate the address will come out to be FC000H, and this will be FD FFFH. 1111 for F, 1101 for D, then again 111 for F. Again this will form the F, F and F. Here 1111 for F, then 1100 for C, then again 000, we are having this address. So you can see here that this is for RAM. And this is also of the size 8K into 8, because we are having 2 RAM chips. Okay, now here if we see the addresses here, FC00 till FDFF, and after that we are having FE00 till FFFF. So you can see that this RAM and ROM, their addresses, they are continuous. There is no gap between their address map. So because in the question we were asked that we have to select a suitable address map. If it is given in the question that use the absolute decoding here, so that the address map, it is continuous. If it is asked in the question that choose the address map such that it is continuous, then you can use this type of addressing, where we will use the A13 address line. It can take 1 value also, it can take 0 value also. So 0 it will take for RAM, and 1 it will take for ROM. Okay, so addresses we have got. Okay, now we are going to draw the interfacing circuit, that how we will interface these 4 memory chips with the microprocessor. Because we have to use the remaining address lines plus the bus high enable signal and A0 to form the chip select signal. So here we will use a decoder for it. The decoder will be a 3:8 decoder. The 3 lines are the input lines and 8 will be the output lines. So 3 inputs will be the address line, BHE and the A0, and 8 outputs they will be used to select the 4 memory chips. Okay. So let's draw the interfacing circuit for it. These are the 4 memory chips. This is our 3:8 decoder. The input lines to this decoder will be the 3 input lines. So 3 input lines will be A0, A1 and A2. A0 will be the bus high enable BHE. A1 will be our A0 address line, and also we are using the A13 address line. So the third input line will be the A13 address line. The remaining address lines we are using to select this decoder. This decoder is having 3 enable lines, E1, E2 and E3. E1 and E2 are active low and E3 is active high. Now this is an gate 7430, NAND gate is there. We are having the remaining address line A14, A15 to A19. A13 is already as one input line. A14 is there, and A14 to A19 we have connected to the NAND gate to enable this decoder. Now ROM, this ROM will have a chip select signal here, which will be called CS1. This will be CS2, this will be CS3 and CS4. Now these chip select signals, they are active low signals, so we have denoted here a bubble. Also the ROM, because for ROM if we want to read the data from here, so we will have an output enable signal. So for these 4 memory chips, we have the 4 chip select signals, and these chip select signals, they are active low. So here we have denoted bubbles over all these chip select signals. Now this is the 3:8 decoder. We are having 3 inputs, so we will have the 8 output lines here. Now these output lines, they are denoted like O0, O1, O2, O3, O4, O5, 6 and O7. We are having bubbles over here, so it will be an active low. Means when we are having 0, 0, 0, so this first O0 will be 0. If we are having 0, 0, 1, then O1 will be 0. That will be activated. So low signal will be available over this. Now if we form a table for the combinations of these 3 inputs and what will be the output, let's draw the table. These are the 3 inputs of the decoder, and A2 is representing the A13 address line, A1 is representing the A0 and A0 is representing the bus high enable signal. Okay, so these are the address or the bus high enable, and these are the inputs to the decoder. Now these three inputs, they can take different values like 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. So 3 inputs can have 8 combinations. Now we will require only 6 from these 8 combinations, because 2 will be used for the chip select signal 1, 2 will be for this, 2 for this and 2 for this. So if we are having we will use only 6 combinations, remaining 2 combinations we can left. So if it is 0, 0, 0, then the operation performed will be even and odd address in RAM. So here both even and odd addresses of the RAM will be selected. So we can say that a word is transferred on D0 to D15. Means total 16-bit data, because even address is also of 8-bit, odd address is also of 8-bit. Here if we see, this is for odd, this is also for odd, this is for even, and this is also for even. So we are having odd addresses from the ROM and RAM and even addresses from ROM and RAM also. So if we are using the first combination 0, 0, 0, then even and odd addresses in the RAM will be selected. If we are using 0, 0, 1, then only even address in the RAM. If we are having 0, 1, 0, then only odd address is there in RAM. So even address means 8-bit address is being transferred. So it means 1 byte transfer on D7 to D0. And when odd address is there, then byte transfer is on D8 to D15. We will use the upper order data bus, and the lower order data bus will be used for the even address. So these 3 combinations are used for the RAM. Now we are left with 1, 2, 3, 4, 5 combinations. So out of these 5 combinations, we will use only 3 combinations, that is 1, 0, 0, 1, 0, 1 and 1, 1, 0. So when it is 1, 0, 0, then both even and odd address in ROM will be selected. When it is 1, 0, 1, then only even address, and if it is 1, 1, 0, then only the odd address, and they are in the ROM. So we are using these 3 combinations for the ROM selection. Okay, if it both even and odd are there, then we will have the word transfer, means 16-bit data is going to be transferred. If it is only even and odd address, then byte transfer will take place. So this is the table where we have the 3 inputs of the decoder and how the 8 outputs they will be used for selecting the chips. For the chip select 1, we will have, because this is for the odd, so for odd address in the ROM, odd address in ROM, we have 110. So odd address in the ROM, we will use the 4th and the 6th combination, because we want this 100 also and 110 also. So this 4th and the 6th output of the decoder, they will be used to form the chip select signal for the ROM. Similarly, for the chip select number 2, because we want the even address in the ROM. So for even address, we will have this 100 also and this 101 also. So we will use the output number 4th and 5th for forming the chip select signal for this ROM. For RAM, we have this is for odd. So for odd RAM, we will have 010 and 000. So we are going to use the 0 and the second output of the decoder. For even, we are going to use the 0 and the first output. So if we form the chip select signals, we will use 2 AND gates here. This is for chip select 1, chip select 2, chip select 3 and chip select 4. Chip select 3 and 4 are for the RAM and 1 and 2 are for the ROM. 1 is for the odd RAM. CS2, this chip select 2, it is for the even ROM. This is CS3, it is for odd RAM, and this is for even RAM. So for chip select 1, we will have 4th and 6th. For chip select 2, we will have 4th and 5th. For chip select 3, we will have 2 and 0. And for chip select 4, we will have 1 and 0. So this is how the outputs of the decoder, they are combined. They are used to form the chip select signals. We have used the 3 inputs because in the steps we studied that we have to use the bus high enable signal also. We have to use the A0 address line also, and the 13 address line is also used. So these outputs, they will be connected accordingly to this logic to the chip select signals of all the 4 memory chips. Now also here we have to connect the read and the write signals. Data lines are also there. So for odd, we will use the higher order address line, and for even, we are going to use the lower order address line. Here also D8 to D15 for the odd and D0 to D7 for the even. Then the ROM is also is only for the read operation. So the memory read signal of the microprocessor will be connected here at the output enable line of the ROM chips. Here we are having for RAM, we have both read and write. So read and write signals of the microprocessor, they will be connected here. Address lines are also there because we are using the 13 address lines to address these memory chips, and remaining address lines we have used for forming the chip select signals. So here we will have the 13 address lines connected. So this is how we can interface the 4 memory chips which are of the size 4K into 8 with the microprocessor. We are here use the 3:8 decoder to form the chip select signal. So in this video, we have solved a problem based on how we can interface the memory chips with the 8086 microprocessor. First, we will calculate that how many address lines are required to address these memory chips, and then the remaining address lines which are left, we will use a logic circuit to obtain the chip select signals for the memory chips, and then we will connect the corresponding control signals for the read and write operation of the microprocessor to the read and write signals of the memory chips. Okay, so in this way you can solve the problems which are based on interfacing the memory with 8086 microprocessor. I hope that this problem is clear to you. Thank you.